Hello students. So in this video we'll see MCQs on atom. First, the radius of atom is of order. So if you see the options, so atom will be of the order 10 raised to minus 10 meters. So option C is the answer. First one. Second, in Rutherford scattering experiment, for scattering angle of 180 degree, what will be the value of impact parameter? Now just for remembrance, so this is a nucleus, or you can say target nucleus. So from here alpha particle are coming, alpha particle, this is also positively charged while nucleus is also positively charged. So when alpha particle comes near this nucleus, it is repelled, so it will move at a certain angle or scatters at a certain angle. When it is head on, means at the center, when it is head on, so it is returning back along the same path. So it gets repelled by nucleus and follows the same path. If it is far from the nucleus, then the alpha particle will move straight. If it is far from the nucleus, it will move straight. So the perpendicular distance of the velocity from center of nucleus, this we call it as impact parameter, and we denote it by B. We denote it by B. Now he has asked for 180 degree, what will be the value of B? So 180 degree means it will go straight head on and again it will return back. So along this line, that is at the center which I have shown. So just I will highlight. So this will be the line for 180 degree. So for 180 degree the B value will be then equal to 0. So option A is the answer. Option A is the answer. Clear? Third one. Bohr atom model. Bohr atom model assumes, first one, nucleus is of infinite mass and is at rest. So nucleus is of infinite mass, this is wrong. Electron in a quantized orbit will not radiate energy. So this is correct. Means if electron is in a stationary orbit, it will not radiate energy. But when it jumps from one stationary orbit to another, there is a emission of energy or radiation of energy. Fourth one, the angular momentum L of an electron moving in a stable orbit around a nucleus is. So angular momentum, by Bohr's postulate we know that mvr is equal to nh divided by 2 pi. So mvr is nothing but angular momentum. Here n is integer. N is integer, that is 1, 2, 3, so on. So if you observe or see the options, half integral. So n is integer, so it is not half integral. So A and D are not the answer. Integral multiple of h by 2 pi. So C is the answer. Option C is the answer. Next, fifth one. In a Bohr's model, the atomic radius of first orbit is R0. Then the radius of third orbit he has asked. So students, you remember this formula. It will be helpful for even competitive. Radius of nth orbit is given by Rn is equal to n square into R0, where R0 is the radius of first orbit. It will be in angstrom units. So here third orbit he says means n is equal to 3. So radius of nth will be 3 square 9 R0. So if you check the option, option C is the answer. Clear? Next, sixth one. Speed of an electron in nth orbit versus principal quantum number n. Graph here is given. Now we know Vn. Again, this shortcut you can remember. It will be helpful for your competitive exams. Velocity in nth orbit is given by 2.2 into 10 raised to 6 divided by n in meter per second. In meter per second. So if you observe, Vn is inversely proportional to n. Inversely proportional to n. So as n increases, Vn has to decrease, means A is not the option, D is not the option. Now if you observe Vn is inversely proportional to n, it will not be a linear, but it will be a hyperbolic curve. It will be a hyperbolic curve. So option C is the answer. Option C is the answer. Next, potential energy and kinetic energy of electron in nth orbit is related as. So general, you remember these relations. Kinetic energy is given by half mod of potential energy. Half mod of potential energy. So kinetic energy will be positive. Potential energy will be negative. Will be negative. Total energy will be equal to minus that of kinetic energy. Total energy will be minus of kinetic energy. So total energy again it will be also negative. So only kinetic energy will be positive. Now if you see the question, potential energy and kinetic energy of electron in nth orbit are related as. So potential energy will be double of kinetic energy from the first expression. That is this expression. Potential energy will be double of kinetic energy. But potential energy will be negative. So means you will have P is equal to 2 times Ke, but Pe will be negative, so you will have minus. Check the options. So option B is the answer. Clear? Eighth one. In the nth orbit, energy of electron is given by formula minus 13.6 by n square electron volt for hydrogen atom. Energy required to take electron from first orbit to second orbit. So energy required to take from first orbit to second orbit is given by E2 minus E1, difference in their energy level. So in the given formula, that is En is equal to minus 13.6 by n square, you substitute the value of n. For first orbit n is 1, for second orbit n is 2. If I substitute minus 13.6, 2 square is 4, minus of minus 13.6, 1 square is 1. Now simplify, you will have the answer. Minus 4 3s are 12, 4 4s are 16, plus 13.6. Now if you subtract 3.4 from 13.6, you will get 2, so you will get 10.2 electron volt. So option A is the answer. Option A is the answer. Ninth one. For the Bohr's first orbit of circumference 2 pi r, de Broglie wavelength of revolving electron is. So what de Broglie told that integral multiple of lambda, integral multiple of lambda, that is wavelength, should be equal to circumference of that orbit. Circumference of orbit. Circumference of orbit means n into lambda is equal to 2 pi into r. Here he says first orbit means n is equal to 1. So if you substitute n is equal to 1, you will have lambda is equal to 2 pi r. So de Broglie's wavelength will be 2 pi r. So option A is the answer. Option A is the answer. Next, 10th one. Which of the following is incorrect? regarding limitations of Bohr's model. This model is applicable to only single electron system. This is correct. This is not incorrect. It does not explain. This is also correct. This model is applicable to all atoms. This is wrong. This is wrong. Means our answer is option C. So option C is the answer. So it is applicable only to hydrogen and hydrogen-like atoms, means single electron. Single electron you can apply. Next, a set of atoms in an excited state decay. In general, to any of the states with lower energy, into lower state only when excited by an external electric field, all together simultaneously into a lower state, to emit photon only when they collide. So if you read, if you take an atom from ground state to excited state, if you take an atom, so you have taken an atom to an excited state. Here it will not remain for long period. Within 10 raised to minus 8 seconds, it comes back to its ground state or to the lower energy levels. So means in general, to any of the state with lower energy. If it is an excited state, it will automatically come to the lower energy levels. 12th, the total energy of an electron in nth stationary orbit of a hydrogen atom can be obtained by. So in previous problem only we had the formula. So energy in nth orbit is given by minus 13.6 by n square, that is B is the answer. Next, 13th, total energy of an electron in an atom in an orbit is minus 3.4 electron volt. Means he has given total energy is equal to minus 3.4 electron volt. Its kinetic and potential energy are. So in previous one question I had told that total energy and kinetic energy will be same, but kinetic energy will be positive, means it is mod of total energy, means kinetic energy will be 3.4 electron volt. So if you see the option, A is not the answer, D is not the answer, because in both kinetic energy is negative. Then potential energy will be double of kinetic energy. So double of kinetic energy, but it will be negative. So minus double of kinetic energy means 6.8 electron volt. So check the option. So C is not the answer. Option B will be the answer. Option B. Next, 14th. The ratio of kinetic energy to total energy in an Bohr orbit of hydrogen atom. So kinetic energy and total energy will be equal, but one will be positive and another one will be negative. Other one will be negative. Means ratio will be 1 is to 1, but one is positive, one is negative, means ratio will get negative. So option B is the answer. Option B is the answer. Lastly, the Rutherford scattering experiment proves that an atom consists of a sphere of positive charge in which electrons are embedded like seeds of watermelon. This is wrong. It is Thomson's atom model, you may say. A sphere of negative charge in which protons are embedded. This is also not. A sphere of electron cloud in which positive charge is placed at the center of a sphere. So positive charge is placed at the center of a sphere. So C is the answer. Please students, hope it will be helpful to you. So request you to refer to your friends and ask them to subscribe my channel